Okay, now on to question 7 and question 8, the blue intermediate questions of exercise 1e. So, question 7 says, prove by exhaustion that n squared plus n is always even for an integer, for n being some integer value. Right, okay, so proof by exhaustion, remember you've got to cover all cases. And of course, it would be crackers, you'd be crazy to go and sit here and go through, well, let's begin with n equals to 1, put it into the expression. Okay, we're going to be getting 1 squared plus 1, which we know is equal to 2, which is even, that's fine, and is 2. Okay, you put that in, 2 squared plus 2, which is 6. Okay, it is even, but proof by exhaustion, you've got to exhaust all possible outcomes. This would be infeasible. You couldn't do it. Okay, so you've got to find a way of being able to represent all of the numbers you can think of. Well, in this case, all of the numbers are either going to be even numbers or odd numbers. Okay, and we know that we can write an even number, n, as something like 2m. That represents all of your even numbers. And then to represent your odd numbers, okay, you could write n to be 2m plus 1. And now if you put these expressions 2m, which are all of your even numbers you can possibly think of, and 2m plus 1, which are all of your odd numbers you can think of, into this expression, hopefully you can factorize out a 2, which will show that this is always even for any number we could possibly think of. So let's begin by looking at the even side of it. So if I go and put 2m into my expression into this up here, let's just see what happens. Okay, so n squared, or n is equal to 2m, so we're going to be getting 2m squared plus n, or n is 2m. Okay, and let's just go and expand out this bracket. So 2m squared is going to be 4m squared plus another 2m. To prove that something is even, you really want to be able to factorize out a multiple of 2. I always like to factorize out 2. It's just the way that we showed it, something is even. So let's take out a 2 here. So factorize out a 2. 2 times by 2m squared gets me back to 4m squared. 2 times by 1m gets me back to 2m. Okay, and now this bit here, 2m squared plus m, is just some integer, just some whole number. Okay, that I can write more simply, because if we can, it's a good thing to write it more simply. I'm going to replace this bit with the letter q. Okay, just to write it more clearly. So let's go and replace this with a q and say that, well, we've got 2 times by this blue bit, okay, which is just some integer q. Okay, and what is 2q? Well, 2q is your 2 times table, okay, which by definition is even. So 2q, okay, is going to be a multiple of 2, therefore it must be even. So there I've considered, okay, all of my even numbers I can possibly think of. Okay, good. Now onto my odd numbers, a similar thing. I put this 2m plus 1, which represents all of my odd numbers, into my expression, and hopefully I can factorize out a 2 again. Okay, so let's do this. So n squared plus n, so n squared is going to be 2m plus 1 squared plus the n on the end, so plus, and n is equal to 2m plus 1, so plus 2m plus 1. Let's go and factorize out, expand out the bracket, sorry, so 2m plus 1 squared, it's going to be 2m plus 1, bracket 2m plus 1, and I'm still adding on that 2m plus 1. Okay, expanding out this double bracket, we're going to be getting 4m squared plus 2m, so plus 4m plus 1, and then plus 2m plus 1. Let's just go and collect up some like terms here. We've got a plus 4m plus a 2m, a plus 1, and a plus 1. So 4m squared plus 6m plus 2. And again, let's go and factorize out a 2, because if we're trying to show something is even, that's what we want to be doing here. So let's do that. Okay, so let's take out a 2. So we can go and get 2m squared. 2 times by 3m gets me to 6m. 2 times by plus 1 gets me back to 2, which is great. And again, like before, okay, this bit, let's do it in yellow. This bit here, okay, that is just some integer, okay. So I'm going to go and replace it with the letter q, because why not? So I've got 2 times by some integer q, because 2m squared plus 3m plus 1 is just some whole number, just some integer, which I'm going to go and write as 2q, which is the same thing as over here. Okay, so 2q again is a multiple of 2, therefore it must be even. And that is our proof by exhaustion. So we proved for all possible cases, for all of our even numbers and all of our odd numbers, okay, that n squared plus n is always a multiple of 2, therefore it is always even. Okay, good. Question number 8 says, prove that when the square of a whole number is divided by 5, the remainder is always 0, 1, or 4. Okay. Now the way that we can think of this is that every number is either a multiple of 5 or 2 within a multiple of 5. And I'm thinking like this because we are dividing through here by 5. So let's write this out a bit more clearly. So I'm actually going to write this up as some sort of points here. So, right. Let's write this. So every number is either a multiple of 5 or within 2 of a multiple of 5. Let's just think about what that line means. I'm just saying if you had a number like 15, well, 15 is a multiple of 5. Okay, so that's the first bit. Every number is a multiple of 5 or within 2. So if you had like the number 16, well, that's within plus 1. If you had the number 14, that's within minus 1. Okay, or if you had the number 17, that's within plus 2. Or if you had the number 13, okay, that's within minus 2. And of course, you could keep going. Okay, number 18 would be within minus 2 of 20, and then 12 would be plus 2 of 10. So you can kind of represent all of your numbers in this way. Okay, so we've got to be able to write all of these cases in 3 possible ways, right? So let's go and do that. So either, right, our number is going to be a multiple of 5m, or our number is going to be 5m, either plus or minus 1 of 15, so either plus 1 or minus 1 of your multiple of 5. So we can go and write that as plus or minus 1, or you can write it as plus or minus 2 of your multiple of 5. So 5m plus or minus 2. Again, with proof by exhaustion, you've got to find a way of being able to write all of your numbers algebraically. Otherwise, you can't literally go through every single case. And we're saying with the question that when we square these numbers, the remainder is always 0, 1, or 4. So now we've got to go through our 3 cases. Okay, this, and this. And we should see that the remainder is 0, 1, or 4. Okay, if divided through by the number 5. Okay, so the first one, let's go and kind of label these up and go and call this one case 1. Let's go and call this one case 2, and then case 3. So for case 1, we're looking at squaring our numbers here. So n squared is going to give me 5m squared, which is going to be 5m squared is equal to 25m squared. Let's go and factorize out a 5, because here we're looking at dividing through by the number 5. So if I take out a 5 here, we're going to be getting 5 bracket 5m squared. Okay. Again, 5m squared, this bit here is just some integer, okay, which we can go and replace with a letter, like the letter Q, okay, which just represents this. So here we can write this as 5Q, okay. Now, 5Q, okay, is a multiple of 5, therefore the remainder must be 0. So let's make a note of this, okay, 5Q. This is a multiple of 5, okay, therefore, okay, the remainder is going to be 0, which is good, okay, because the remainder is either 0, 1, or 4. That's my first case when my number was a multiple of 5. I can either have plus or minus 1, a multiple of my number 5. So let's go and consider this case now, down here. So let's go and consider case number 2. Okay, where I've got, let's just go and look at 5m plus 1 to begin with. So n squared is going to be equal to, you know what, let's just do it in one go. So let's go and do your number, which is 5m plus or minus 1 all squared. So either that's going to be equal to, expanding the bracket, so it's either going to be, sorry, let's write it out a bit longer. So 5m plus or minus 1 bracket 5m plus or minus 1. We're just expanding up a pair of double brackets. So it's either going to be 25m squared, either plus or minus 10m. So either plus or minus 10m, and then plus that 1, but either plus 1. Sorry, it must be plus 1 because negative 1 by negative 1 is always going to give you plus 1. So plus that 1, which is there. Excellent. And then again, let's go and factorize out a 5 now from this part here. So we're going to be getting, that's equal to 5 bracket 5m squared plus or minus 2m. Okay, and I've got that plus 1 lingering on the end, which is good. Okay, so I've got this plus 1 on the end. Again, this bit here, this 5m squared plus or minus 2m, that is just some integer, some whole number, which I can go and replace just more simply by putting the letter q there, just to represent this part here. So this I can rewrite now as 5q plus 1. Okay, and this is a multiple of 5. 5q is the multiple of 5 plus 1, which means the remainder, if I divide 3 by 5, will be plus 1, because 5q is a multiple of 5, like 5, 10, 15, 20. So if I divide 3 by 5, okay, that will simplify down, and the remainder will be plus 1. So we can write this here. So this is going to be a multiple of 5 with a remainder of 1. Okay, which is good, because the question is saying, remember, that the remainder is either 0 or 1. So in the first case, we had the remainder of 0. This case, we had the remainder of 1, which is good. Now for the third case, let's go do this one down here for my case number 3, which was my n value being 5m plus or minus 2. So n squared is going to be equal to 5m plus or minus 2. I'm squaring this bracket. And again, this bracket, kind of written up in long term, is 5m plus or minus 2 bracket 5m plus or minus 2. Okay, so this bracket expanded will give me 25m squared. I'm then going to have plus or minus 10m. Sorry, plus or minus 20m. So plus or minus 20m, because I've got two lots of the 5m twice, and then plus or minus 2 squared will always be plus 4, because negative 2 squared will give me plus 4, so plus a 4 on the end. And this is good, because now again, if I go and factorize out this part here, take out a 5, we're going to be getting 5 bracket 5m squared plus or minus 4m. I've got that plus 4 lingering on the end. And like before, okay, this bit here is just some integer, which I can replace with a letter, like q. So we're going to be getting a multiple of 5, 5q plus 4, which of course is really, really good, because the question was saying either a remainder of 0, 1, or 4, which is good. So this is a multiple of 5 with a remainder of 4. So you can see, if I can zoom out and get it all into one page, if I can, it's going to be a little bit cramped, but we can kind of roughly see it, hopefully, which is good. Okay, we've been through the 4 cases either, and we've proven this for all of our numbers. Okay, by setting it up at the start, we get a remainder of 0. Okay, when we had a multiple of 5. Okay, in this case, we had a remainder of 1 for a number plus or minus 1, then a multiple of 5, and we had a remainder of 4 for plus or minus 2, a multiple of the number 5. And these three up here cover all of the numbers that you need, that you can possibly think of. Okay. Hopefully that was useful. Thank you for watching, and we'll look at question number 9 on the next video.